A very, very warm welcome to everyone who's joining in from across the globe. And I think we have a really healthy participation. I see people joining in from Nepal, from Canada, Mumbai, Shillong, well, lots of places, Lebanon. So the list is now sort of coming in. Yeah, so this is quite the global classroom for us. So warm welcomes again. I'm Dr. Naveen Thomas. I'm an associate professor and the vice dean at the School of Government and Public Policy. As you know, we have a very interesting 1 year master's in public policy at the OP Jindal Global University, which we've partnered with Coursera to host over their platform. And it's our 3.5 years into this program now, and it's been a fairly interesting journey. The new leg in this journey is that we've transitioned from a 2 year master's degree to a 1 year master's degree, which is going to start on the 1st of April, and applications are open for that. Having said that, well, a little bit more about myself. I'm an economist by training, and I direct the online program, the program in public policy. And today we are here to discuss an extremely important and topical um, topic, for that matter. That is how do we leverage AI in public policy? And I think this is the right time to have this discussion. The policy space is abuzz with how this tsunami, this technological tsunami, is disrupting the way we're doing everything, and that's bound to spill over into the way we do public policy as well. But the public space is quite different when we think about it, when we compare that with the private space, or the tools that the private sector offers. And the way we need to think about public policy and the use of AI technology in public policy is hence slightly different and is worth additional debate. And I'm glad that we have a healthy participation here to add to that debate. So today we have two panelists. Both of these faculties also teach at the online program. In fact, they teach courses on data science in the data sciences track of the Masters in Public Policy. First, we have with us Dr. Sharik Syed Hussain. He is a faculty at the Jindal School of Government and Public Policy, a fellow at the Jindal India Institute, and a member of a fairly unique center that we house at the School of Government and Public Policy. This is the Center for Complexity Economics, Applied Spirituality, and Public Policy. He's a PhD in Computational and Integrative Sciences from the Jawaharlal Nehru University in India. His research focuses primarily on studies of data-driven complex systems. Our second panelist is Dr. Sushant Kumar. He is also an assistant professor at the School of Government and Public Policy, and he's also the assistant dean of social outreach at the school. He is a PhD in public policy from Northeastern University, Boston, and he's been a fellow at the Harvard Kennedy School's program in science, technology, and society. Most of his research focuses on science and technology policy issues, focusing specifically on governance of artificial intelligence technologies. Now, I think that we have a stellar a stellar panel to discuss this very topical issue. And I think let's start with Professor Sharik. And I think let's hear about perspectives of how the data-driven aspect of AI is changing public policy. Over to you, Professor Sharik. Sharik, I think we have a bit of
Audible?
bad internet there.
Which I often use data artificial.
Uh, would it help if we Yeah. Do you think you can let's try out without your video? That might save a bit of bandwidth for you. Uh, yeah, now it's better. Yeah, this is good.
Okay. Okay, fine. So, right. So the very first thing is like we are living in the era of data, and the popular phrase is like zettabyte era. The present era is also referred as zettabyte era. That is 10 raised to the power 21 bytes. And according to some reports by Petrock Taylor and others, by the end of this year, we are going to generate 180 zettabyte of data. That is tremendous data. Okay. So that means a large volume of data. But then, since the scale of the data is increasing, we have to explore some patterns to have good social welfare scheme, good policy making, good decision making. And that's why it is very essential to have machine learning and AI based technologies employed to extract meaningful pattern from these data. But before we go into the detail of this thing, let's have a question. Do we have similar thing in the earlier history or in the earlier civilization? So after exploring this, I came to know that there have been several civilizations that used to have different types of data mechanism, and that data is in a different form. For example, let's say Egyptian civilization used to have rain papyrus. Why? Because of the flooding of Nile. A lot, and because of that flooding appears continuously, and they have to change tax mechanism because of the fluctuation in the Nile. And so they need a very precise measurement. And then they came with certain ideas, rules, and device for tax incentives or labor management, because Egypt is known as the land of pyramid. Second is like Babylonian civilization, where they used to all the cattle, honey, vegetable, and other. That means there was some mechanism through which earlier civilization also collect data. And there is a thing that we say data. Whenever data is there, to extract information, and that information is to facilitate decision making. Now it is on to extract this information from large volumes of data. So we have in the historical thing, we have Rhind papyrus, we have cuneiform script, we have clay tablet, and nowadays, and later on, we have printing punch machine that used to decode everything through punch hole and I spot. Later on, nowadays, what we see, what we perceive through data is an electronic arrangement of numbers, which is true to some sense, but it can be text as well. For example, we have our passport that says this is the person's name, this is his address. So my address would be, let's say, 92 E and then some street. Okay. Now that means I can have data as numbers, I can have data as text. So when numbers and text integrate, we have a heterogeneous type of data. And since I was discussing about zettabyte era, we have large volumes of data. By the end of this year, we are going to generate 180 zettabyte data. That means we have to deploy some mechanism that we can extract meaningful pattern from this large volume of data. Now, coming to the second problem, most of the time in social processes, what we see two variables with each other. That is that is mainly like a regression mechanism. We see how one variable fluctuate with another variable, and then we tend to say, okay, this variable has this type of relationship, and then we generalize this relationship by using some logic. But nowadays, it seems that one to one variable generalization is not sufficient, because sometime we have another variable that is constant for that particular duration or that particular window, but after a certain time period, let's say something else happened and it got triggered. Once it's got triggered, it leads to a very different outcome that we have anticipated. So these type of pattern we try to extract by using machine learning and complexity theory as well. So during this course, I would be discussing about the aspect of complexity theory as well, whereas using Python to interact with the real world data, how this pattern emerges. Let's say our transportation pattern, or let's say I come from the Jindal School of Government and Public Policy. So in my, let's say I have 50 students, and then I asked a student, how many of you like Pepsi and how many of you like cola? And then after this question, I am going to have certain answer, which is nothing but their responses. So that is, but their responses and my interaction with my class. So this will come into account, and then I will use Python or any other language to capture some pattern. So let's say 30 said they prefer Pepsi and 20 said they prefer cola. Okay. Now I said to one of my research scholar, can you please go to other professors' class and take a survey how many of them like Pepsi and how many of them like cola? So then after surveying through the entire JSGP ecosystem, I will get roughly around, let's say, 40 faculties. So I'm going to have these 40 bunch of responses. So, I was interacting with my student one to one, later on 40 faculty and several students. That is, first it was one digit, that is me. Then I interacted with a group of student, two digit, extended this interaction as JSGP. Again, now it is going to be in three digit, because we are having several thousand student, or 1500, 1600, whatever be it. Then I will extend to the entire JGU, which is Jindal Global University. And now I am going to have offline and online choices of, let's say, 10,000 students. So you can see how these microscopic interaction of some choices are resulting and creating a data pattern for Pepsi and for cola as well. Again, if I can extend this for the entire nation, or let's say globally, then I will see the price fluctuation of share prices of Pepsi and cola by just these choices. Okay, so that is the interaction. So my choice, my interaction, my ecosystem creates. I interact with Naveen in a specific way, I interact with Sushant in a specific way, and then I interact with my family in a different way. That is again these interactions. So that is data is interacting. I mean, we have data points and we are interacting with each other differently. And this pattern is very helpful in decision making. For example, if I say there is a possibility of having rain tomorrow is around 50%. So you will not possibly pay attention to this forecast. Okay, you'll say, oh, it's just 15%. Let's not take this. But then all of a sudden you got a message that there are 90% possibility of thunderstorm or rain. Then you won't miss to take your umbrella. So that's how number affects our decision making. And when we want to extract certain pattern from these volumes of data, then we come up with certain types of numbers, certain types of probability. We have language model where we have subject, verb, object. And in some languages, it is subject, object, and verb. Okay. So let's say English and French, they have a little bit different structure, but then you can have a probability of assigning a word, and then what can come after this. So I am a professor. So I is a probability, and then after I, a is less probable than m. I am, and then a professor. So that's how probability comes into picture, and this play a crucial role in data science. Later, we will have three different types of data. One is structured data, So structured data is like very relational database, comes from relational database. Let's say I have a group of students and then their attendance, or a group of subject and the marks for any student. So that is a relational database or relational data. When we have this relationship very clear, it is very easy to do data analytics onto this. So this is a structured data form. Sometimes we have some, not sometimes, but more often we have data. Unstructured data is like that comes into our email or in social media account or in WhatsApp chat, because we have words, we have some emojis, and we have acronyms as well. Okay, and when the place changes, let's say I am in India, I use certain types of letter, and let's say in Lebanon or in US there are some different types of word that are used for this type of conversation. So this data is unstructured data. Then comes again a third quality of data, which is semi structured, where we have to pay a little attention, but we have to filter a lot of things. So structured data is easy to model. Then comes unstructured. Unstructured is a real challenge where we use all of the data techniques. First data mining, and sometimes data scavenging. After cleaning of the data, we can have a heterogeneous file. The file could be of crime. Okay, then we can have insight of crime pattern. At some places the crime would be economical, at some places the crime would be violent in terms of, let's say, uh, murder or something like that. And we also can have economical data, financial data, and then we can build upon this. Then comes the concept of time series analysis. So in real world, time series is like non-stationary, that is its mean is not constant. So we will discuss this in detail. But real time series are a little challenging. Then we have certain measures in module. And then comes the machine learning aspect. So as you see, I was discussing about data, then I discussed the type of data. After discussing the era, we are too much of data, so types of data, and then I am discussing about the pattern. So if we come from the reverse side, it will be AI. First thing, AI is deep learning based, and then deep learning is based on machine learning. And machine learning is trained on real data. So that's how it is divided. First we have real data. On real data we run machine learning algorithm, and the machine learning algorithm generates some pattern, then we gain some insight. And later on, if we want to further extend this to deep learning model, then after deep learning we can have AI deployed model. That is the thing. And then again, we use certain types of algorithm. One is like multi-dimensional scaling. So in one of my work I have used conflict data. So what multi-dimensional scaling does, well, multi-dimensional scaling reduces the dimension of the data, because social sciences data is high dimensional. It reduces the dimension and then mapped it onto a projection plot, where the countries or the actors are behaving in a same are grouped together. So let's say my data was conflict based, then I saw Iraq, then I saw Afghanistan, then I saw Sudan. So these type of countries together, and Italy, France, Netherlands separated. So that's how machine learning model, which is here multidimensional scaling, helps to project and separate these cluster and to gain deeper insight. But there is again another side of this, which is sometimes the model that we use, it does not interpret or capture the reality as it should. And then there is a concept of algorithmic hate or algorithmic oppression, because they don't understand sociological process, right? It is we who can gain insight from that data and then recommend it is possible to deploy this model, or we can leave this, or we need to train this data further. So for example, when we started this work, let's say 8 years ago, if you search a doctor on Google, it will display a doctor who is a male and white. right? So then the gender dimension, gender dimension was missing. Then later on, Fariba Karimi and others have made several research articles, and then Google changed its algorithm, modified it, and nowadays it's much better. Same is with the women of color. Like if you type a black women, it is going to it will take you somewhere else. If you type Asian women, again it will take you somewhere else. So there is a scholar in US, and then she worked on it. Further, there is a resistance from Google and other companies, but later on it was sorted. Third aspect is like just like we have a CIBIL score when we take loans. So there are some students who are very I mean, able or very deserving to have loan, but because they live in an area which is deprived of like the CIBIL score is not good for the people who are living in that particular locality, and then this algorithm suggests that we should not give loan to such candidates. So this is again creating some sort of inequality. So that's the second aspect where we have negative feedback. Otherwise, most of the time, for this type of scale, we have to deploy this type of machine learning algorithm to capture the pattern. But sometimes we have to stay cautious. We have to stay with the ethics, and we have to follow. I mean, that should be integrative and enriching. So that's a holistic perspective. Okay. So I have few more things to discuss, but I think I spoke a lot. Is it sufficient, Naveen, or should I speak
Yeah,
a
I
little
think
more?
this is good to start with. You've really taken us through how data is structured and where the real kick and power of AI comes in,
Hmm.
especially when we think about deep learning,
Yeah.
and how that can be problematic as well,
Hmm.
especially when it comes into the public sphere. Right,
Right.
so you can choose not to use Google, or you can choose not to use Facebook, but it's very rare that we can stop not interacting with the government, or we can stop interacting with the government. Now, when
Yeah.
governments start using AI to analyze the terabytes of data that you're talking about, to, let's say, deliver better policies,
Yes.
and that those deep learning insights can have biases, and people really don't have a choice in not interacting with the government because they'll be dependent on the government for several public goods, then things become complicated.
Hmm.
Right. So while there is a fair amount of power there, that there is a word of caution as well. And I think this is a good pitch for Sushant to give his thoughts on this, because he works on issues of democratic use of AI and challenges in the governance of artificial intelligence technologies. Over to you, Sushant.
Thank you, Naveen. Thank you for very well-pitched introduction and segue into my side of presentation. Um, I will start with just sharing my presentation, and then we'll go from there. Um, so hello, everyone. Can everyone see my screen?
Yeah, yeah, we can.
Yes. So I'm Dr. Sushant Kumar. I'm also assistant professor with JSGP, Jindal School of Government and Public Policy. I'm a PhD in public policy from Northeastern University, and I'm a Harvard Fellow in Program in Science and Technology Society, which shapes my take at how we think about artificial intelligence and public policy. The title of the webinar was Leveraging AI in Policy Making, and my pitch and my presentation will take you to understand, without understanding how AI works and how it interacts with governance processes and societal issues, you can't really leverage that for policy making. So I'll try to expose you to more critical side and more kind of issues that are coming up with technology. So we'll start here. This is a snapshot of Google AI when it was asked how much glue to add to pizza. It got really viral once upon a time, and it suggests you very nicely that you should add like 1/8 cup or 2 tablespoon of white non-toxic glue to pizza. And I'll suggest why that really happened. This happened because this particular bit of data was taken from a Reddit post, which was sarcastic in nature. Now, that is where the problem starts happening with chatbots and LLMs and large language models, which takes information out of context and without understanding human emotions behind those sources of data. So this was supposed to be a sarcastic post, but it was taken as it is and verbatim supplied to people, which led to obviously disastrous consequences, right? Nobody wants to add glue to their pizza. But this is not a one-off problem. So hallucination itself, Cambridge Dictionary named it Word of the Year for 2023. To explain what hallucination is very basically speaking when AI technology tries to make things up, things that they do not exist, right? Like lawyers quoting cases that don't exist, or chatbots coming up with academic references that don't exist. And that happens quite often, right? According to a study in 2024, chatbots detected AI references 30% to 90% of the time wrongly or incorrectly, right? So it's a systematic problem. And it happens because when you compress like trillions of parameters into billions, let's say, which is where LLMs operate, you lose information, right? And then there is bias in training data, then there is incorrectness in training data, all of which leads to outputs which can be problematic, right? And you have to keep these things in mind when you're thinking about AI models in policy making, that all of this is happening. By the way, this can be rectified. We'll talk about rectifying and solution side of it towards the other half of the presentation. But first, we will expose ourselves to what are the issues. So hallucination being one, but that's obviously not the only one. This chart here comes from a Nature study, which summarizes different models on the left here, their names and their rates of hallucination. So you can see there are models which are hallucinating up to 30% of the time, as in like one third of the time they will be giving you wrong responses. Although there are good models as well at the bottom, for instance, OpenAI's O1 Mini and Google's Gemini 2.0. These are like good performing models, but there are models even by Google or Anthropic. Cloud is also like 17% of the time it has hallucination rate. So these are something to keep in mind, that AI models and large language models, generative AI can give you very made up outputs, and something to keep in mind, right? Then not just hallucination is the problem, there is a problem with bias, as Sarik also talked about and Naveen also pointed out, about predictive algorithms and bias, right? And that most basically happens because of historical data on which AI models are trained, right? And you see that example most prominently in facial recognition system, which is deployed in criminal justice system. In predictive policing, you will see quite often. On airports, you will see quite often, where facial recognition technology powered by AI is used to detect criminals, let's say, or offenders, the next offender in line. But the problem is, like with anything social, the historical data is also infused with a lot of biases, right? It has information which is skewed towards certain communities. So usually, as it happens, as sociological research suggests, countries across the globe stereotypes and criminalize a marginalized community much more than the majority community. So people of color, in Indian case, people of lower caste, people of minority communities like religions like Muslims, for instance, they feature much more in criminal justice system data compared to other communities. So given that your historical data is biased more or has more data points of these communities, there is systematic chances of AI models throwing up output of these communities, people looking like them much more, or flagging them in airport much more than people of or white people or people of like Hindu upper caste background, for instance. So there is systematic issues of bias embedded in predictive algorithm that you have to keep in mind, right? Then other issues happen with future of work. A lot of us debate about this idea that AI is going to make us obsolete, it's going to make us jobless, and we are going to run out of things to do. Although not all of them are completely unfounded, there are issues that that the research is suggesting that AI can eliminate entry-level jobs, and senior professionals would use AI to automate tasks that are more manual looking. So there will be an economic disparity that you, as policy researchers, as policymakers, have to keep in mind, that there is going to be a lopsided nature of workforce later on, because certain kinds of jobs are going to be hit more than certain other kinds of jobs, right? Then there's a problem of chicken and egg, where firms would in future want to employ more and more people who have more serious domain specific knowledge, but candidates won't have them because they are not able to join the workforce because of automation in the first place, right? So you're going to exclude people from that pursuit of getting business specific knowledge in the first place. So there's a chicken and egg problem that we are looking at in future as well, and as policy researchers, something to think about. And then there is a creativity concern also about work, where much of the work that we do, if it's going to be automated, then the roles of people are going to be relegated to doing reviewing kind of work for generative AI. So for instance, there is a data point which says 13% of code in India right now is produced by generative AI, and the role of programmers have shifted to reviewing and verifying the code. So there is a problem of like creative satisfaction of job, as in your job would be relegated to reviewing the output created by the generative AI models, and your role will be constrained to making the model more and more better at your own cost, at your own expense. So that is again something to think about when you're thinking about policy issues and AI models, right? Then another concern is about ghost workers, where AI models don't work without labeling of data. Somebody has definitely labeled these data as what is Apple, what is orange. Computers don't know anything. You have to pretty much train it to think about anything or everything, right? And this kind of data labeling work is very precarious. It's very, sometimes it exposes people to very violent content. For instance, on social media, people who do content moderation work are exposed to very violent graphic kind of work. And most of this work happen in global south, which are countries of basically underdeveloped countries and developing countries like India, and countries from Africa and South America. So people do these kind of very, very precarious and dangerous, violent jobs, and even prisoners are involved in doing these kinds of jobs. And these kind of jobs already, although precarious, so Facebook recently, after Trump administration came in power, announced that it is going to wind down its content moderation work, and they're shifting more towards what is Twitter's model of community notes, which basically uses AI models to basically detect speech or information which is troublesome. So even this precarious job of content moderation, which was done by people in Global South, even that is under threat of being automated. So that is also something to keep in mind. Then there's another problem of beta testing, where a lot of the scientific ideas before being unleashed in developed world are what are tested in countries of global south, and that has happened before. Like Tuskegee experiment was another example. Cambridge Analytica in 2017 Kenyan and 2015 Nigerian election, they used algorithmic tools in these contexts before they deployed it in US and UK later on. So there is like a very strategic choice made to test out these dangerous technology, or technology which are not foolproof, or the technology which are not proven safe for humankind. They're tested out in global south context and then exported back to places which are more regulated. But in this process, people of global south really are harmed in this process. So that is something again to think about when AI models are still being built out. They're still being tested. They're tested on people like us much more than white people of Western countries, for instance. There's something for a policy makers to keep in mind, right? Then there's a lot of concern about gender bias as well. So LLM generated reference letters, for instance, have been found to exhibit gender stereotypes. Like it will use descriptors like stand out in the industry or a true original with men, and stereotypes like kind and communicates well with women. And that happens because of the male data bias in the data corpus that you are feeding. Given that the societies that we live in are patriarchal in nature, so our data is also infused, the literature is also infused, the policy texts are also infused with male stereotypes, right? Where women are stereotyped as certain kind of human beings, and that keeps on perpetuating when you're using AI models to train on their data and give you future predictions or predictive models that you're trying to create out of it. And then women also are have relatively less access to internet, and they have relatively less digital literacy and literacy of any kind relative to men anywhere across the world most of the time. So that impacts their ability to access LLM models, which has to be kept in mind when we are thinking about gender parity in the access of AI models, right? Then on a discourse level also, there are problems where we hear about quite a lot of risk framing or like risks related to AI. in place of thinking about fundamental questions about purpose of AI in the first place. So the thing with risk framing of AI is you try to take the technology for granted and talk about the side effects of the technology or the risks emanating out of technology, and you try to control that, right? So, but in that process, you miss out the really fundamental question of, do we even need the technology? In what context do we need the technology, and how we can keep people first and keep people safe while we are deploying the technology in society, right? And in this process, while the data for AI models is contributed by public widely, so you and I and everyone in this webinar are contributing data points to AI models, but we have very little say in the governance of these models. So there's a very lopsided structure here in terms of who is contributing, who is training the model, and who is really having a say in the design, in the deployment of these technologies. So that is a very fundamental policy question to keep in mind when you're thinking about AI, right? Um, so this slide kind of gives you a sense of, I don't want to take you into technicalities, but this is a paper from 2020 which went into the data sources of ChatGPT and GPT-3 more particularly, and found the sources of data and which data was given more precedence or less precedence, right? So I wanted to focus on the table on the right. So Common Crawl is one source of data, which is basically entirety of internet data, right? Web text 2 is like Reddit data, which has 3 or more votes. That is how ChatGPT defines it. And books 1 and books 2 are not entirely clear what they are. And they are purposefully vague because they violate so much of copyrights. So that is the reason it's not very clearly laid out what books they are. And then there is Wikipedia. And the weights assigned, if you could see, web text 2 has the highest weight, which is Reddit posts with 3 or more votes were given highest weightage when training the chat GPT model. And these books, which are mostly self-published novels, also have very high weight. And Wikipedia also has very substantial weight of 3 here, which is, as you know, like Wikipedia, we don't even consult when we are doing research because it's not credible enough. And it also has gender bias issues and issues of other kind. So there is a lot of problem with the fundamental data corpus on which these LLM models are trained, right? So then the question becomes, how do we govern AI, right? So researchers and international bodies around the world and governments around the world have laid out a couple of ethical principles on which you can think about regulating AI. So the idea of transparency, as in how the model really works, where is the data really coming from, who is contributing the data, becomes a very important principle on which to test AI governance models. So transparency becomes a very important ethical framework. Then the idea of accountability, as in when the AI models go wrong, when it harms people, who is accountable? Is it the deployer? Is it the people who are inventing the technology? Who does the responsibility really lie with? So accountability system is very important. Then justice and fairness, as in to make sure that the benefits and harms of the technology are equitably distributed across community, so that not one community or marginalized community are not disproportionately bearing the burden of the technology. Like as we discussed in the idea of ghost workers or beta testing, certain communities are paying the price more, and they have to also pay the further price by the imposition of these technologies when they detect black people wrongly, or when they flag people of color wrongly on airports. So certain communities are paying the price more. So we have to make sure that these technologies have its benefits and its harms equitably distributed across communities. And that is the idea of justice and fairness. Then privacy, of course, data privacy has to be respected. It is one of the very important fundamental right in the era that we live in, and doesn't need even to be explained further. Responsibility, again, as in like who is responsible when these models become more and more powerful over the course of time and assume more and more power, right? And then non-maleficence is the concept of non-harm, as in to make sure that technology is not harming the people on which it is being used. So these principles help us think about policies when we are thinking about AI, right? And going from there, researchers have also suggested the need for a global governance body for generative AI. We have examples in the past to draw from, like in the nuclear era, we came up with International Atomic Energy Association. So things are not completely bleak. There are examples in the past to emulate, to get inspired from, to work from, basically as a model. And nuclear technology and nuclear energy gives you one of those examples to emulate from. We need bodies which are independent and have binding decision powers on countries, on corporations. And then we need technology which is societal demand driven than just technology push driven. As in, we hear many times a technology is created in Silicon Valley and then being pushed onto the world community without even thinking about whether there was a need for it or whether the society really demanded that technology or not in the first place. So there is a need for impetus shift in terms of thinking about the technology is more societal demand driven than just push driven by technological sector. And then we need wider engagement of stakeholders, including people from civil society and nonprofits and people who are working really on the front lines of advocating for people's rights in a very consultative two-way manner, right? So these have to be kept in mind. Another thing to important thing to keep in mind is thinking about existential versus immediate risks. So we are often trapped in a situation where we think about existential risk coming out of AI, as in humans are going to be turned obsolete and they're going to be completely made extinct by AI technology. So those are like very futuristic, sometimes even speculative concerns. But compared to that, there are immediate risks that policymakers have to keep in mind. So for instance, when a faulty algorithm, AI algorithm kicks people out of healthcare plan, so like health insurance industry uses a lot of predictive AI technology to predict whether to give or not give somebody a health insurance program, right? And then facial recognition technology imprison people. So these are like a really immediate and actual concerns that are being created by or made worse by AI technology at times. So being policymakers, we really have the responsibility to make sure that we are thinking about these immediate risks that are emerging out of AI technologies. For example, EU AI Act is really leading the pack in terms of governing the AI technology. So what it does that it comes up with a risk-based framework. It defines AI technology in 4 different levels, from unacceptable risk to high risk to limited risk to minimal risk. In unacceptable risk, it talks about technology like social scoring or using AI for predictive policing. And it completely bans those unacceptable risk technologies. Then in high risk comes a slightly low risk technology compared to unacceptable risk. It talks about AI models being deployed in healthcare, in criminal justice system, and it comes up with very harsh constraints on these technology. And then limited risk are relatively less risky technology, including chatbots, and there are transparency requirements about it. Or less regulation compared to high risk and unacceptable risk. And then there is minimal risk technology like spam filters and stuff, and which pretty much go without any kind of regulation. So this kind of coming up with a graded approach to different kinds of AI, rather than having a blanket ban or a blanket green flag to all kinds of technology, we can come up with more nuanced rules, right? So EU has like strict rules for high risk technology. It has transparency requirement for different kinds of AI. It has the idea of regulatory sandbox, which is very important, which encourages AI development through control testing environment. As in, instead of unleashing the technology on the real world right away, you test out these technology in controlled environment for a certain amount of time before unleashing them to the world, like controlled trials in drugs and pharmaceutical industries case. So EU has come up with those regulatory sandboxes, which can be emulated as policy makers across the world as an idea to draw upon, right? And then also the idea of fines for non-compliance to make sure that corporations are accountable. Compared to that, India's approach is slightly different. It pushes for the idea of sovereign AI, that countries like India or in countries in similar position to India are thinking about data sovereignty and building its own foundational models, right? And it also tries to, it's trying to focus on creating chips like GPUs, which are required to build these AI technology, build its own foundational models, and build its own AI applications subsequently, right? So it is hard to avoid geopolitics in the case of AI, especially after the DeepSeek came out and this was released by China. We saw like pretty much like a geopolitical Cold War happening between US and China, and other countries are also like chiming in, right? Like India is responding in its own way. It is ushering its own entrepreneurs to develop its own foundational models. Other countries are also getting nervous to a certain extent. So there is like almost a race between different nations, almost like a space race or like nuclear arms race of 20th century. And what it does, like in a worst case scenario, it drives countries in a race to the bottom in terms of developing more and more powerful technology, less and less regulated atmosphere, which can be really detrimental to people. So it's something as policymakers to keep in mind, like what really are our needs, rather than being caught up in a geopolitical whirlwind of creating more and more powerful technology. So I'll conclude with few thoughts that in a global AI race, which concentrates capital, data, and computational power in certain countries, there is an idea of digital public infrastructure. as in where governments kind of try to take the onus of building digital public infrastructure on which these AI models ride. So that can really help avoiding big tech monopoly, which leads to all kinds of exploitative colonial kind of consequences. So that is rather more equitable model of thinking about creating foundational models which are led by the government initiatives. Um, then there is need for cautionary use of private investments in social sectors leveraging AI, because since this technology is so powerful, there is a risk of profiteering in many sectors in which, especially in critical sectors like healthcare, where like health insurance plans people can be kicked out of because corporations would try to maximize profiteering. So something to really keep a watch on. Then there is a need for better regulation. A permissive regulatory apparatus means that states and companies can use and process citizens' data with impunity. So there's really need for strict regulations. There's obviously a need to ramp up data privacy and security. And more than anything, there's a need to make training data more inclusive and broad-based. So as we talked about different kind of biases, a lot of these training models are based on data which is very skewed, very limited, usually very much embedded in Western context, and certain kind of communities, it represents much more than other kinds of communities. So as policymakers, when we are thinking about creating foundational models, we really have to keep in mind to make the databases and the data corpus of these models as broad-based as possible. And then there is finally a more proof of concept required before pledging public resources. So there is a lot of, in the geopolitical race, countries are pledging resources after resources, which are very crucial, and diverting that away from other important public infrastructure issues. So there's more concept of proof required before we deploy more public resources in this technology. So some things to keep watch on. So I'll stop there, and we can, I think, take questions, Naveen.
Yeah, thanks, Sushant. This is quite fascinating, and it sort of really ties up the foundations and the applications of generative AI that Sharik was talking about. And we have a cautionary note here, but it's still something that needs to be actively debated, because AI has hit us. Uh, I mean, well, it's disrupting the way in which we're doing everything, and it's happened so quickly that I think governments and people at large have been taken by surprise how quickly it started permeating into our lives. So I think the debate is on this is extremely interesting and relevant. Let me start off with a question, let's say two questions, and then we can take more questions from the Q&A Q&A box. So the first question I have is the entire problem in the way we are looking at AI because we see this as a superhuman silver bullet solution to all our problems? So, is that the problem to begin with? And a lot of the worries that we are thinking about may be unfounded, because at the end of the day, we are socializing or we are informing AI just the way we inform, let's say, an individual. An individual goes through a process of socialization. They go, they live certain, they imbibe certain biases that they are raised with in the society, in their respective societies. Is this the way we should be seeing AI, and hence temper our expectations from that, and not see AI as superhuman, but more human, or humanize AI and hence humanize the fallibilities that intelligence and human intelligence has, and make that as an attribute of AI rather than sort of um, uh, let it operate without any checks and balances, which is primarily what people are worried about in public policy. Yeah, I'll let you very quickly answer both of them, and then we can move to the chat box. We've got a couple of really nice questions there.
Like, you want to go first, or I can? Okay, I'll just try to very quickly address some of the points that are coming to my mind. Thanks, Naveen, for that question. And humanizing AI could be a really good approach to think about policy regulations. Thinking about silver bullet idea of looking at AI, I think like we all live in a world of technological hype where framing of many of these critical technology or cutting edge technology is done in a way where promises are really inflated, and the expectations really have to be kept in check. I was just reading a article today about like how much of AI is credited with how much scientific progress it can bring. And when we look at our LLM models, like we are really like working with a model where we feed enormous amount of data to it, and then we get that data back in return. Basically, it's like a more sophisticated Google search engine. So compared to that, and thinking about really cutting edge scientific progress, maybe some kind of a place in future that we really want to get to. But there's definitely like a lot of hype around the technology, and we really need to look at the technology for what it is, to be able to govern it, to be able to use it in a informed manner. And there is also the idea of scale and speed, as in like the scale at which AI really works, or AI models really work, is where most of the change really happens. Like you are right, like you can look at this technology as the way we are training an individual, we are also training the technology. But this technology takes data from entirety of internet, and I mean, that is the exact concern with AI, that it can be used by non-state actors to automate, let's say, cybercrime. So the scale and the speed at which AI can really take some of these social concern is what really concerns me as a policy researcher and as individual, and something really to I would want to keep in mind. Yeah.
Sharik, would you want to add to that?
Yeah, definitely. So definitely agree with Sushant because of the scale of the data generation. As I earlier mentioned, that it is a zettabyte scale, and the scale that we are generating this data, we have to when deploy this type of model, but at the same time we have to be equally cautious and transparent, because what happens sometimes there are third parties who have access to our data, or let's say in the policy frame. We just click on it and accept all the terms. So then what happened, our profile is generated based upon our digital fingerprint, and that profile is being sold to third parties, where we have to stay cautious. That means they have to have some institution and answerability, and the proper use of this AI based infrastructure. And third thing is like the people who are working into this. So there was a wonderful article by Professor Sophia from US, and she mentioned that at one instant there were some employees even in the Google who believe that women are less capable than men, and that's why there must be some biases, and because they were training this model, that's why there were some biases in the model. So this is where we have to stay cautious, because it's a public data but in private hands. So that's where we have to stay cautious. Government can be involved. So there are two actually framework. One is California based framework, and another is European GDPR, where how our data is being processed and what are our rights in terms of protection of our data. So these two still in the nascent stages, but these are very crucial. And after a lot of resistance from tech giants, these are being implemented. And I think uh, this should be implemented with certain transparency, and some institution should be there for the answerability of these things. And there is one more point, that is about the pattern that we are generating. So every time we generate the pattern, that is different with respect to certain geography. We in India are generating a different type of pattern, and let's say somebody in US is generating a different types of pattern. So if it is bi-directional, let's say government to public and then public to government, then it is more robust and more transparent. And just last point, I will add on to Sushant is like we have two different types of language. Language is like gender-based language, English, he, she, Hindi, and so on. But there are some language which does not discriminate on the basis of gender. So when we translate that she is a doctor and he is a babysitter, the translator automatically translate it as he is a doctor, she is a babysitter. So these are some of the biases that really need to be corrected.
Thanks, Sushant. Sorry, thanks, Sharik. Let's take some of the questions that our participants have posted. The first I'll take from Atmanandan Jayaraman. Um, so you know, at the end of the day, most of the AI technology is not being developed by governments, but they're being developed by private multinationals, large corporates who aren't necessarily tied to any particular country. And if regulations become very strict, they might just relocate and operate in shadows and still make the profits that they're making, or do the research that they need to do without much governance. Now, his question is, well, AI governance needs to be global, but the first step towards that is each country having their own foundational model, and the biases in the technology are such that it's not something probably accessible, uh, or let's say having a foundational model will require certain number of GPUs and certain computational power, which is also not democratic. Now, how can we think of global governance if the globe itself is not uh, a party to governing AI policies?
Okay.
Right. So, yeah, Sharik, why don't you go first and then we can hear from Sushant?
So the first thing that I mentioned before this, that there are two rules. I mean, one is California based and another is European framework for carrying out economic activity and so on. So these type of rules should be there. I mean, they are with respect to each country, and they should be. And then we should be worry about who is the custodian of our data, if it is government or if it is a third party, right? So when it is the third party, then we really need to worry about that. And if it is the government, then government is going to use it in framing certain evidence based decision making, evidence based recommendation for certain health policy or uh, nutritional policy, agriculture based policy, or water resource management, and so on. But if there are third party involvement, because most of the time sometimes we don't have that type of infrastructure that requires fund, we use different types of models. So then we hire third parties, and then we say, okay, you process our data, give us some insight, and then we make policy. Then it is really risky. Then we have to be in the proper legal framework with respect to the country of whom the data is being processed, and we have the transparency. We should have the transparency as the California law says or as the European framework says, with respect to adaptability of our local ecosystem. So that is the thing. And then institution is there, transparency is there, then we are pretty much having lesser risk in terms of our data processing and profiling of our each digital fingerprint. So that's how
Sushant,
we
do you
can
want to
reduce
quickly?
the.
Thanks, Sharik. Sushant, do you want to quickly respond?
Yeah. I think I just want to add to Sharik by saying that we, like each country, do not need to wait for creating its own foundational model before we come up with a global governance body. And nuclear energy is again like an example. There is only 5 or 6 nuclear power existing, but we had International Atomic Energy Association existing because there is a risk of also other countries developing that power and more than countries, non-state actors developing that power. So you don't wait for each country to be equipped with having their own foundational model before you have global governance mechanism. Another point is that all of us are already implicated in foundational model because of data. That each of us are training the data, and the data is largely going from global south, where most of these social media companies, big tech companies source their data from. So all of us are already having a stake in this puzzle that is evolving, right? So we cannot dissociate ourselves, even if we don't have foundational model. We are training OpenAI's ChatGPT because all of us are using already. So that is we are already included in this mess of a thing that is unveiling. So we better have a global governance mechanism, I would say, without waiting for that moment to come.
Yeah, thanks, Sushant. Unfortunately,
So
we've
I was actually
run out.
working on this.
Sorry, you. Yeah, Sharik, go ahead.
Actually, I am working on this nuclear aspect and with respect to nowadays AI policies. So here I would say, yeah, so International Atomic Agency is doing great, but for some point, again, there are some biases in it as well. If you see and explore this, its inspection and the way it inspect, that's one thing. And second is like that the processing of data that I said, uh, the transparency and the processing. It is not necessarily that we should have the entire framework. The data goes from here. We are using anything like Gmail or anything, that our data is being processed there. So I raised one thing: custodian of this data. That's the crucial point, and how it processes that data.
Thanks, Sharik, and thanks, Sushant. Unfortunately, we've gone over time, and there's a fairly rich number of questions that we've left unanswered. But I think that that'll have to wait for another opportunity to discuss that. In any case, both Professor Sushant and Professor Sharik teach on the online program that we have, the Masters in Public Policy. You can check out our program on the link that we've shared. And hopefully we'll keep this conversation going. I thank the panelists for being here and taking time out. Both of them have had long days at the university, and still they've kept up a very enthusiastic note in their presentations. Many thanks, and I also want to thank all the participants who've joined in from across the world. This has been a great opportunity to speak on this, to speak and interact and hear your thoughts on this really, really pertinent and important issue. Thank you, everyone.
Thanks, Naveen. Thanks, Sushant.
Thank you.